Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everybody. I would like to say welcome you all to our workshop, En route workshop, Transition to Sustainable Energy. En route developed by Climate Interactive and MIT Management Sustainability Initiatives. This is my contents. I will start with a simple introduction about En-ROADS. Later on, climate change and energy, transition to sustainable energy, and I will finish with my conclusion. Let's start with En-ROADS. En-ROAD is a cutting-edge simulation model used to test climate solutions and generate climate scenarios for the future. Climate change, including energy production, land use, carbon dioxide emissions, and temperature rise. Users can adjust a wide range of variables and assumptions to explore the potential outcomes of different policy interventions and technological advancements. For more information about En-ROADS and how it works, you can watch our first work by using the link. The name was Hybrid Workshop on Climate Change and Simulation of its Scenarios using En-ROAD Tools. It's held on 22 November 2022. For more how practice En-ROADS, you can watch our second workshop. Also, you can get our link. And the name was Hybrid Workshop Series on Climate Change and Simulation of its Scenarios using En-ROAD Tools 2, From Theory to Practice. It was held on 10th of May 2023. Practice En-ROADS. You can also watch our third workshop. This is the link, and the name was Hybrid Workshop Series on Climate Change and Simulation of its Scenarios using En-ROAD Tools 3, Practice on Smart City. It was held on 3rd November 2023. Now, this is the new topic now. I will talk about the climate change. Climate change refers to significant and lasting changes in weather patterns over an extended period, typically decades or longer. It's largely attributed to human activities, particularly the emission of greenhouse gas like carbon dioxide, methane, and nitrous oxide, which trap heat in the Earth's atmosphere, leading to global warming. Now let's talk about the greenhouse effect. This figure shows us perfectly what is the meaning of greenhouse effect and how it is occur. Some solar radiation is reflected by the Earth and the atmosphere. Most radiation is absorbed by the Earth's surface and warms it. Some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. Infrared radiation is emitted by the Earth's surface. This is an interesting figure to show us, to compare natural greenhouse effect, human enhanced greenhouse effect. You can easily compare by using this figure. What is the difference in between each other? Now, the topic is climate change and energy, the main topic of today. Climate change and energy are deeply interconnected, as the production and consumption of energy are significant contributors to greenhouse gas emissions, which drive climate change. Here is how they are related. Fossil fuels. The burning of fossil fuels like coal, oil, and natural gas for energy is the largest source of greenhouse gas emissions. These emissions include carbon dioxide, methane, and nitrous oxide, which trap heat in the Earth's atmosphere and contribute to global warming. The second one is renewable energy. Transitioning from fossil fuels to renewable energy source, such as solar, wind, hydroelectric, and geothermal power, can help mitigate climate change by reducing greenhouse gas emissions. Renewable energy technologies generate electricity with little to no greenhouse gas emissions, making them a crucial part of efforts to combat climate change. Energy efficiency. Energy efficiency improves efficiency is buildings, transportation, and industrial processes can reduce the amount of energy required to achieve the same level of output, thereby lowering greenhouse gas emissions. Energy efficient technologies and practices can also save money and improve energy security. Decarbonization. Decarbonizing the energy sector involves reducing or eliminating the use of fossil fuels and increasing the share of low carbon and renewable energy sources in the energy mix. This transition emission reduction targets outlined in international climate agreements such as the Paris Agreement. Electrification. Shifting energy demand from fossil fuel-based sectors like transportation and heating to electricity can help reduce greenhouse gas emissions, especially if the electricity comes from renewable sources. Electric vessels, heat pumps, and electric appliances are examples of technologies that support electrification efforts. This is a new topic, transition to sustainable energy. The transition to sustainable energy is essential for mitigating climate change, reducing air and water pollution, enhancing energy security, and fostering economic growth. Here are some key aspects of this transition. Let's start with renewable energy sources. Transitioning from fossil fuels to renewable energy sources such as solar, wind, hydroelectric, geothermal, and biomass is crucial. These sources produce electricity with minimal greenhouse gas emissions and have the potential to provide a significant portion of the world's energy need. Energy efficiency. Improving energy efficiency in buildings, transportation, and industry can reduce energy consumption and greenhouse gas emissions. This includes upgrading infrastructure, implementing energy efficient technologies, and promoting behavior changes to optimize energy use. Another topic is electrification. Shifting energy demand from fossil fuel-based sectors like transportation and heating to electricity can help decarbonize the economy. Electric vessels, heat pumps, and electric appliances offer cleaner alternatives to their fossil fuel-powered counterparts. Smart grid and energy storage. Developing smart grids and energy storage systems enables the integrating of intermittent renewable energy sources into the grid, enhances grid reliability, and facilitates the efficient use of electricity. Battery storage, pumped hydro, and other storage technologies play a crucial role in balancing supply and demand. Policy support. Governments can accelerate the transition to sustainable energy through policy measures such as carbon pricing, renewable energy, mandates, subsidies for clean energy technologies, energy efficient standards, and phasing out fossil fuel subsidies. These policies create incentives for investment in renewable energy and drive innovation in clean technologies. Research and innovation. Continued research and development in clean energy technologies are essential for driving down costs, improving efficiency, and overcoming technical challenges. Investments in research institutions, innovation hubs, and public-private partnerships can accelerate the deployment of sustainable energy solutions. Community engagement, engaging communities, stakeholders, and the public in the transition to sustainable energy is vital for building support, addressing concerns, and ensuring that the benefit of the clean energy are equitably distributed. Local initiatives, education programs, and participatory decision-making processes can foster collaboration and empower communities to take action. Now, this is the last part of my speech. I came to the conclusion. This is my conclusion. In conclusion, the transition to sustainable energy requires coordinated efforts from governments, businesses, civil society, and individuals. By embracing clean energy technologies, improving energy efficiency, and implementing supportive policies, we can create a more resilient, equitable, and sustainable energy system for the future. What we want to practice together in this workshop. Thank you very much for your attention and participation. Now, Mr. Farhad Bolouri will present En-ROAD simulation. Thank you again.
Thank you so much, dear Professor. And also hello to all of the participants. Now I am using En-ROAD to showing how and what Professor Dr. Hüseyin Gökçekuş explained during his presentation in the En-ROAD tool. When you write En-ROAD in your Google, you can see the first one from Climate Interactive. If you click on it, you will have the En-ROAD like this, the website. You will have here many tools for use, but what we want today is to use the En-ROAD modeling. So when you click, you will come to here, the part of the this tool, which one is the version of the 24.4. It is the updated one. Here you have, firstly, I want to explain it very shortly what you can see in this website. If you want with the details, you can see, as a professor mentioned in our first workshop, second workshop, we explained all of these tools with the details. But if you want to see it shortly now, here we have the language from Deutsch and English until Arabic, Persian, French, and Japanese and Chinese. We have in the language. If you want, you can click in your language, also Turkish, and you can see it in your language, all of the material. Also in the simulation tab, you have the recent policies. All of these 18 things that you see here, they are your policies, defined as policies in this website. Also, you have assumptions. Some minutes later, I will mention some assumptions. Up here, you can reset them. Also, you can reset all policies and assumptions too. Up here, you have assumptions that I mentioned some minutes later. Here, you have the graphs. Here, you have two main graphs, as you see. And also, you have so many graphs up here, as you see here. Also, in view model, you have the main graphs like these two graphs you can see, and you can change these graphs. I will explain to you. Also, you have Kaya graphs. These are the Kaya graphs, which one shows global population, GDP, entire, and the other things. Also, you have minimized graphs. As you see here, GDP, cost of energy. You have so many graphs here, and when you click one of them, it comes to here to figure show for you. Here you have some action and outcomes. I will show you. For example, if you do so many things here, maybe sometimes you forgot what you did, or you want to see what you did in detail and what is the effects of these things that you did. In that time, you can come to here and click on action and outcomes. Here it shows to you which actions did you do, and also which outcomes you earn instead of it. And also here you have the metric units that we are working with them, and also US units, and also play sound and showing graphs. And in the part of the help, you have so many materials to helping you to have to work with this tool, which one we are doing today. Here you have the thing that all of the things coming to the first one. Also, I gain it to our main graphs. Here is to reset all the graphs. Also, it is for the last action. When you have so many actions and you want to see the last action. For example, here I put the administration as my last action. If you click on here, it shows to you automatically which action you did lastly and what is its effect on, for example, green gas net emission. Also here, when you click, it shows you full screen for you, the website. Also from here, you have the minimize graphs. Up here, you have just help. Up here, when you did something like this, in the end, you can share with this one your link in your paper or anywhere in your Twitter, in your email or anywhere. When anybody click on that link, it comes directly to this model with these actions that you did. Okay, now I am going to show some tools that we have here, and after that I start to explain to transition to the energy that we are doing today. Firstly, I want to do all of them, reset all of the policies. Firstly, I want to say that as we mentioned today, to transition to renewable energy and to new energies, if you see here, the energy is very important in this modeling. First of all, I must mention that En-ROAD's model is based on energy. All of the model based on the energy, but as you see here from 18 policies, 8 policies directly related to energy. Also in transportation and building, all of this you see energy efficiency or electrification, they are directly about the energy too. And also in here in deforestation and methane and other gases, and also technologies and afforestation, all of them are related to the energy. So this is a good tool when you're talking about the renewable energies, transition to good energies. It is a good way to using this tool in your works. Now, if I reset all of these, and also I want to show you in assumptions too. In assumptions, if you see here, you have something about the Earth system, economy, but if you see about the energy, you have so many things. When you click here, for example, you can see years to achieve energy supply taxes for subsidies, for example. You can here change it, for example, from 10 years to 15 years, or years to achieve energy efficiency improvement rate. If you want, you can change it from 10 years to, for example, 15 years. All of these assumptions are changeable. You can change it if you read something in your papers or books. You can change this assumption. These assumptions are with the MIT Salon. They put these things, but if you write or read any other things in the books and papers, you can change these assumptions. When you change something in the assumptions, as you see here, becomes blue. That shows and remind you that you changed something in the assumption of the model. Without any action, maybe there are no change, but when you change something, there are some different outcomes because of that change that you did in your assumptions. Now I reset all of these assumptions and all of these things. Now I want to show something before going to my modeling in the model. Firstly, I want to show you here. Here you can see the list of the things that you can get from this model as output, or you can get it as figures. Here we have, firstly, I want to mention the historical. For example, greenhouse gas net emission history. As you see, this one, gray one, is about the historical, and the other one is about the En-ROADS, okay, the black one. As you see, En-ROADS can cover the historical data. So this model is valuable and reliable, and you can honest it on it. So now I want to show something, for example, impacts. This model can show you the impacts that you have on something, for example, in air pollution or sea level rise, that when we talk about the climate change, always we thought about the sea level rise. For example, I do here some policies. For example, I use these things, and also renewable energy I use, nuclear I use, net zero carbon I use, carbon price I increase, energy efficiency and electrification in both building and transportation I increase, decrease in the population, economic growth I decrease it, deforestation I decrease, afforestation I increase, methane and other gases, and also technologies. Okay, now you can see sea level rise from the baseline comes to down, and it is better. And also a better picture, here you can see it. This is a new tool. In a map, you can see this sea level rise, where is it dangerous or where is it better. Now it comes, yes, here you can see, for example, I write here Cyprus land. I want to show you how is it in danger, which part. As you see in TRNC, there is no danger part from sea level rise or parts in the danger. But when you saw the south part of the Cyprus in here, in Limassol area, as you see, near Limassol Salt Lake, you have an area that is in danger, and it is in risk if some policies doesn't do, and if sea level rise going like this until 2100 or 21st century, it is in the risk. If I show it in view layer, yes, as you see, this part is in danger. And this is a new tool in En-ROADS, and you can see everything clearly, how does it affect climate change something. And also you can show it in a window, as you can see here, and how is it going to be in 21st century. Yes, as you see, this part is in danger, as I mentioned. You can change it here, and you can also change it on the map. For example, I want to see it 2050, how's it going in the danger. Yes, you can see it is little, but after a long time, it is going to be in more risk. Yes, in this picture I showed you, sometimes if you need, here you have a description about the pictures with this three dots. When you click, you can see the description about what is this figure showing to you. Also, you have, as I showed you, you can view it in the layer in the bigger map, or also you can show it in a new window. And also, if you want, for example, in the other things, I will show you. For example, when you see the greenhouse emission, you can copy the data. For example, now I copied it. You can come to your Excel file, you can paste the data, and also from here you can get your own graph. Yes, you can see. it is exactly the same that you have in the En-ROAD, because it gets to you all of the data. It is yearly data, so you can have exactly the same graph in your Excel file. From here, we have these ones also in the impact. I want to show you some interested and other things. For example, air pollution. Yes, air pollution, PM 2.5. If you see, with these policies, we decrease it from 27 megatons to maybe, yes, it is near 3 megatons. We decrease it more than 22 or 25, nearly 25 megatons. We can decrease it with these policies. But these policies are very optimistic. As you see, we decrease all of the bad policies and we increase all of the good policies, but in the end, you can see how it affects, for example, on the air pollution. In the impact part, you have so many things. For example, temperature change. You see, if it goes like this, it is more than 3.3, but if it goes with this policies, it is 1.3, which is below what United Nations and IPCC working group wants us. Also in here, you can see air pollution based the pollutants and also sources. Also, for example, here, it is a new graph too. For example, it shows the frequency of extreme heat and what is the situation today with plus 1.3 degrees Celsius, and also baseline, if it is going what we have today, it means 3.3 in 29 years out of 50 years, it goes like this. And also, if it goes with our scenarios, it goes to be like this, and it is very good. Here in impact figures, when you go to the website, you can check more and the other things. I don't want to miss our time only with the impact part. So I am going to reset all of my policies and simulation, and also I want to see our graphs. Yes. One of the things that Professor mentioned, and today is important for us in energy supply, is net zero carbon, because it is exactly shows energy transition, what we need nowadays. So when we do this net zero carbon, let's us to see what is its effect. Up here, if we want to see primary energy demands, here we will see, for example, for coal. As you see, the coal, what we need decrease because we use new zero carbon energies. So our coal primary energy demand decrease. Also, for example, if you want to see, for example, oil decrease, but is a bit. Also, if we want to natural gas, yes, about the natural gas, if you check, it's decreased our demand for natural gas, because as you see, we are using net zero carbon, and because of that, our need to nature gas primary energy decrease. Also, if we want, for example, a bioenergy, it is decreasing. All of these energy demands also nuclear. As you see, our need to nuclear primary energy demand decreased too, because we use new zero carbon, and because of that, we don't need so many nuclear or coal or oil or another energies. But if we want to see in total what is happening for energies, for example, which one I can show to you? Yes, firstly, I want to show this. We said in coal, oil, natural gas, even in nuclear and bioenergy, our energy demand decreased, but because now we have net zero carbon, so our final energy consumption increased. This is because of the financial, you know. I'll show you here. When we have these ones, as you see, cost of energy. Because we increase new zero carbon energies, because of that, with the economic rules, our cost of energy decrease. And because of our cost of energy decrease, our energy use increases. Yes, as you see, this is the economic rule. So when you decrease your new zero carbon energy, because of that, you decrease your oil, coal, and also nuclear and bioenergy, and also natural gas energy demands. But because your cost of energy decrease, your final energy consumption increase. But as you see, it is good because your energy consumption increased. It is a fact, but your energy is coming from new zero carbon energy. But Professor mentioned it is a transition to energy. So you are using good energy and good energy resources. So it is not bad for your nature, and also you have here a decrease in your greenhouse emissions, as you see here. It is the baseline, and it is what you earned with only this policy. And also, when you want to change something here, you can put your button on the three dots. You have so many information here. For example, here, if you want to put it, for example, 1.7, you can do it here. Also, you can change some assumptions from here. Also, you have here so many graphs, related graphs. You can show it for yourself to see how is it going and what you want to change. Also, here you have so many data. It shows to you what is it showing for you. As you see, all of them, they have these three dots. I come to here to show you something. Yes. Here you have the examples, big message about it, key dynamics about that policy, co-benefits of it, videos about it, some slider settings about it, and also model structure. But I want to show here, it goes to En-ROADS more detailed for you, and key dynamics and everything for you. Here we have a good picture. I want to explain it for you. These are the models that we have behind this En-ROADS model, because as you know, there are 14,000 formulas behind this modeling. When you click only one policy, in the same time, 14,000 formulas working to show you this graph in some seconds. So now I want to show you why we have some delays here. It shows to you. When in your company, research and development sources say to you in, for example, 2023, you want to new zero carbon energy, you want to do it in reality. When you want to do it, research and development sources want to do it, and they make some policies. Only to take this action in your communicable ready to do, it takes more than 20 years. And also it comes to capacity in development. And if you want to improve it from capacity in development to capacity for construction, it takes minimum 5 years. And also when you want to improve your capacity in construction to capacity in use, it takes 5 years too. So in total, when you want to do something and you have an idea to come with fossil fuels capacity in use decrease, it takes 30 years, which you can see here in your En-ROADS. And for example, we did our policies from today. It is 2024. But as you see, the change are starting around 2054, as you see. So it takes 30 years to your policy working in reality. This is what shows you in this modeling. from this three dot and from this part, you can see these things. And also you can see potential co-benefits, videos, and anything else that you need. Also, I want to show you another things. For example, I reset all of my policies and graphs. Yes, here when you use this modeling with your own laptop, you can see all of these options, and I suggest to put all of them in the minimum and maximum parts to see their change and effects on your modeling. For example, here I do some change, and now, for example, if we want to see some another pictures, for example, in our food, land, and forestry, what is the effect? And also in our financial energy and final energy. Firstly, I want to reset all of them because I want to show only net zero carbon, what is related for our today issue. Here we have the energy types, as I showed you, and also I mentioned all of them for you. Yes, for example, when you increase your new zero carbon policy, you can see the decrease in your carbon intensity of final energy. You can see you decrease it. Also, good pictures that we mentioned and another. Yes, as I showed you, your final energy consumption will increase. These are what I showed some minutes ago for you, and also from here you can show them as the aerial graphs. If you want, you can use them as aerial graphs. And CO2 emission. CO2 emission is important too. When you did something, you can see how is it your policy effects on CO2 emission too. And you have here so many different graphs about the CO2 emissions, and you can check them one by one, and which one you need, you can copy it. As I said, you can copy the data and just put it on the Excel file, and you can have your own graph, which one you want to use in the papers, or also when you want to put it in your paper or your report, you can use these ones too. For example, you can put it in the new window and take a screenshot of it, because it is in a very detailed and very high quality graph. So you can use it like this and copy it, and you can paste it in your report. Also, if you want to show somebody, you can use it like this and show how is it going. As I said, we are doing the policy in 2024, but it starts from around 2020, 2054, because of the delay that we have between our policy and action and its effect on the reality. Up here, as I said, you can see all of the change that you can take. What you can change here is only the first option. But if you want to change the other options, you must come to here to change some of them from here. As I mentioned, you can change them based on the things that you read on the reports, books, and papers. You can change from here, and also you can come and from the assumptions. You can change something if you know about them. For example, up here, I say about the coal it is not right. For example, about the oil I want to change it like this, or about the gas I want to change it like this. You can change from the assumptions too. As you saw, when I change something in the assumptions, we have here the change because it's affect all of the modeling. So these are the things about the energy, but not all of them. And also I want to show only this part. This part is directly about the energy supply, and also as I mentioned in the first, in the transportation and building, you have energy efficiency and also electrification in both of them, and these are related to energy too. For example, from here you can see what we change, what we can change, and what is its effects. For example, in transport sales or in total transport, you can see how is it affected from electricity share or your final energy consumption by the area, or this one, that it not changed by this policy so much. And also from energy efficiency, for example, up here, you can see how we can change it and how's it going. For example, for this one, for building and industry, it is starting by this year. But you can change it. You can say our policies is starting by, for example, 2050, and you can see how is it going to be changed. Up here, as I mentioned, you have the information and you can get and do the things. And also here, and when you did these things, you can come here and see your impacts on, for example, air pollution. With these things, you can see how you decrease your air pollution with these policies. And this model is a global. When you did something, it means you did it in all over the world, or you will do it in all over the world. And you can see its effects in the future for all over the world. Also here you can have something about the population and economic growth that it is not related to energy, but how is it going to affect on your air pollution, and also I can share it, show it here, energy, final energy consumption. But as I said, as an economic rule, when your economic growth or your GDP increase, you have more energy consumption because you have money, you want to use more energy, you want to be more comfortable. So you use more energy, and as you see, your policies going to be down with this economic growth. But when your population decreasing, it is better for you. When it is increasing, as you see, it is a worse scenario because with the increasing in population, your energy consumption, and with that one, your air pollution and all of the effects of the energy consumption are increasing. Also, in the end of this one, I want to show just the methane because it is very different from the other things. Perhaps about the methane, if I change it here to yes, the methane is a bit different one, or CH4, because when you did so many things with the energy sector, you do all of these things. Just look at this blue one, CH4 or methane. As you see, I do so many policies here, and all of them are good policies. But even there is no change in this blue one. It is methane. Why? Because when you do something about the energy and afforestation or deforestation or technologies, you are doing something about the CO2, not methane. because methane is only related to some related and special issues. Now I show you. We did so many policies. We decreased our degrees Celsius from 3.3 to 1.7, but we didn't do anything for methane. But only for this one, because if you see here, the methane is related to, as I said, very specific things. For example, SF6 or HFCs, and also it is related to us to cows because of our food and the other things. It comes from this source, and also from here you can have so many examples and big messages and key dynamics about it. When you decrease this one, yes, now you can see the decrease in the blue line because you can decrease in the methane. And as you see, it has a good point and good effect on our global temperature and our methane in the world. So it is a policy that we must make more attention about it, because, as I said, it is a special issue. With the energy sector, we couldn't do anything for it. It is exactly about our foods and the other things. Okay, now I think it is enough for now, but if you have any question, please let me know, and if you have any other things. But for now, I want to say it is finished today because so many things, as I mentioned about the primary things for doing this modeling, we mentioned in our before 3 workshops. And today, Professor explained about the transition to energy, and you saw, and I tried to show them in practice in the En-ROADS tool. But you can check also En-ROADS website for more videos and for more webinars and workshops they have. And also we are continuing our workshops with Professor too. So thank you so much for your participation. And thank you so much, Professor. I'm at your service. Thank you so much.
Thank you very much for this wonderful presentation. But I actually have one small question. Is this software had anything to do with water resources and
No, not with water. As I mentioned, you can see, for example, this impact on the sea level, for example, but no, it is not related for water. It is based on energy, and so many of the things are related to energy. For water, you can just explain it for water-related things. For example, deforestation, afforestation, you can use them in assumption part, and also in the modeling from deforestation, afforestation in something in your building, electrification. In these parts, you can see the effects, but directly, no, it is not related
Thank
to
you.
global research.
Thank you.
You're welcome. Okay. Yes.
Lord,
Lovely.
also thank you for the knowledge addition.
Thank you.
Okay. I want to understand what are the data here to be used for full scale publication. Like you want to do some publication on a global scale, like climate change,
Yes.
and the implication of this policy.
Yes.
So can this data be used?
Yes, yes, it is easy to use. As I said, yes, there are so many papers, and if you check in the Google Scholar or in the other resources, that they use this data in their papers. I used to before. Yes, as I said, when you change something, you can come to here and say what you did and what is the outcomes. You can copy it up here, your actions and outcomes. And also from here, you can copy your data and come to Excel file and get your own graph, or take up here your graph up here, copy it and paste it in your paper and just mention it. And also from here, you can copy the link and put it in your paper as the resource. anybody can come and check what assumptions and what actions you did. They can check it, and also from the other parts you can copy paste in your paper and mention it, and you can use that.
One last question, please. I actually want to ask you about the renewables in the energy section, energy supply section, renewables. Can we actually see the effect of one type of renewable energy? For example, can I specify wind energy or can I specify solar energy to see its effect in the...
Yes, yes, exactly. They have this opportunity. Thank you so much for your question. I can show you. Here we have they specified it for, yes, for example, yes, here we have wind, solar, hydro, geothermal, and the other renewables. When you decrease it, and from here, as I said, you can come, as you see, for example, hydrogen, you can change it. Other ones you can change it. Renewable tax, the other things, as you can change, or you can go to assumptions, and in the related part with the renewable energy, you can change them. For example, you say, yes, about the hydro, it is not this, or about the wind, I want to do this, or change it from here, for example, 75. Yes, you can change all of them and see what is happening for you.
Thank you very much. Very useful.
You're welcome. Thank you. Thank you all. Have a nice day. See you in our other events. Thank you so much.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.